Hello and welcome to the your last session of Tech Ed 2011 before the lock note. Welcome to ARC, COS, MID 208. I'm not sure we could have actually got any more, a bigger cross-section of tracks in one hit. Welcome to Architecting Real-World Azure Applications. My name's Doug Bauer, and this is my colleague, Brad Smith. Just a quick show of hands. How many people have heard of MYOB? Excellent. The brand manager will be exceedingly excited. Next question is, I'll actually say something. In our PD department, we seem to have a bit of an addiction to M&Ms. It's just something that we do. We're always eating chocolate and junk food as part of our job. Anybody else share that kind of addiction? Just a few people? We've decided to provide M&Ms, so it might be a slightly more encouraging out there to get everybody involved. Excellent. Yes. See, it's amazing how to encourage a dev audience. It's awesome. Excellent. Yep. Yep. Look. All done? Pretty sure it's me. I think I'm electrified now. Yeah? Excellent. Hopefully this will encourage everybody to last to the last session. Whoa. I'm going to explode soon, I think. All done?
Yep. Noise, take it off. Yep.
Okay.
Text volume.
Just close.
Still noise.
Still going. Okay, it looks like I've turned into a rock star and now I've got an actual microphone. I'm not going to be beatboxing for everybody, so everybody's kind of safe. It must be. Yep. So today what we're going to do is we're just going to talk about our learnings. MYB has been on a journey over the last 10 months, about 10 months, where we've actually taken an app and our predominant app and actually started to deploy it into Azure to extend our market. We'd really like to just share with you a number of the learnings that we've had from our experience so that potentially you can also take advantage of what we've learned. So what's on the agenda today? To start off, I'm just going to give everybody a run through of who MYOB is, what we do. Then we're going to start talking about the architecture of where we've actually come from and how we've then transformed that to work with the cloud as well. What we're going to do is share with you a number of stories of things that we've learned along the way, things including how we tested for scalability and load testing, other things including latency, compression issues and things like that, and a few other things along the way. So who is MYOB? There's a big show of hands of who knows about MYOB. But what MYOB is really all about is making business life easier. Now, at the moment, we're doing that for 1 million plus businesses in the Australian and New Zealand market. But traditionally, I think we've been known more as just the box product that you buy in most of the stores, Harvey Norman and things like that. But we're actually a lot more than just the one product and service. And as we've got a few icons there to represent some of the products, certainly not all the products. Some of them include MYOB Atlas, which is our collaboration with Google, where we're actually providing free domain name registration and websites to small businesses around Australia. We've also got a range of products for the small to medium business, and that's including live accounts and account right. Live Accounts is already a web-based product. We've then got specific tailor-made products for the accounting segment. That includes Accountant's Office and Accountant's Enterprise. And we've also got some products that actually work in the enterprise space, being the XO Business Suite. Yep. Good to go.
Just steal that microphone for a sec. So, what's the best way to make a story come to life? I reckon characters. And I'm going to talk about my stepdad and also my uncle. My stepdad is Trevor. He's a plumber. He lives in a country town in Victoria. He's a sole trader and he has limited technical experience. He rarely uses a computer. When he does his accounting, it's a chore. He doesn't want to be there. He doesn't want to finish it. He just wants to get it out of the way, and he wants to take his books to his accountant and just have it happen. The one thing he does have, though, is internet. And so, because his kids want to access the internet, he's got internet. He doesn't actually use it himself. The next person is Ray. My Uncle Ray writes software, sort of like what I do. He has a small business, though. He doesn't work for MYOB. He travels overseas for work. He works from home. He's excited by technology. He has iDevices. Now, I could say iPads and iPhones, but everyone seems to be saying iDevices today. And he's also got Windows phones, and he's connecting from outside of his office. So he likes playing with his computers. He writes software for a living. He also wants his accountant to be in his business. Now, what I mean by that is he wants his accountant to be able to be able to access his records anytime he likes and pick up on those things that make him more profitable. Work out that he's got too much inventory in excess CDs for his mastering. He's spending too much money on salaries this month. He's overexpensed on stationery. He wants to be able to pick those things up early and not once every 3 months when the BAS goes in or once every 6 to 12 months when he has to pay tax. It makes his life easier.
So as these two users have kind of demonstrated, our client base is varied. Now, there's actually many thousands of different business types that MYOB and the range of products that we actually provide service, as I said, in the Australian New Zealand market. What you're actually looking here is the current range of boxes. Today, we're only going to focus on one of those products in the range, and it's actually the AccountWrite range. I should have mentioned that earlier. And this is actually the AccountWrite range boxes that you can physically buy at the moment. The existing market product of the top 4 of these products is actually built around C++ source, and we actually use C-tree as a data store, which actually represents a company file. So, or what we call is a company file, and is actually like one of our clients' businesses. What we've actually done is we've actually released into the market our new platform. So we've actually started to replace old technology suite, and that's shown there with the AccountWrite Basics on the far left. Over time, we're actually rolling out and replacing all of these products as we go. The product range itself actually, as I mentioned, services the thousands of different business types. Now, it actually does that because it has quite a flexible feature set, and it actually allows a business to actually pick up which product in that range they actually want. To give it a bit of relevance, Trevor, the plumber, he has quite small requirements. So he's actually at the bottom end of the product range. He's not interested in payroll because he is a sole trader, and payroll only comes into the suite about halfway along. Other features that we've actually got is it's a basic CRM, which is in the full product suite, inventory management, purchase management, sale management, that kind of stuff. So the new platform that we actually started, as I mentioned, there was most of the old one was based around C++. And the start of our journey, even before 10 months, well and truly before 10 months ago, was actually just a product rewrite. We're actually intending on replacing the existing C++ platform with a current set of technology so we could extend it into the future. So initially what we actually started to do was build a WinForms-based client using link to SQL for the business logic layer. We used domain-driven design to design and flesh out all of our requirements, and we're actually using SQL CE as the data store, or the company file, as I mentioned before. You might actually ask why we used SQL CE. Why didn't we just go with SQL Server? This decision was taken a fair while ago and was based around our requirements of having to install SQL Server onto potentially 700,000 desktops around Australia and New Zealand. We had a significant amount of problems or issues that came up, and just the installation story for SQL Server in an environment that we don't have control of was actually quite difficult. So we ended up going with SQL CE because the installation story for that is exceedingly simple. It uses very small memory space, so the varied hardware that this is actually expected to run on is much more capable of dealing with it. When we developed what we had very clearly delineated layers of responsibility. We were very strong on that, and it's actually served us exceedingly well on our journey to convert this to the cloud.
Layers.
Pardon?
Layers.
Layers.
WinForms, link to SQL.
I already have.
Okay.
Yep.
Sorry. Proven wrong.
Yep. Awesome. So this is in effect represents one client out in the marketplace. So they have this installation on their machines. But once this thing actually gets out in the wild and you have 700,000 odd installs of it, you actually end up with this kind of pattern where every single one of these installations is actually working completely independently of each other and bears no resemblance to every other one. Full customization is available, so every one of these data files, the contents of it can be potentially completely different to every other one. So this raises a few issues for our client base. The client is currently tied to their machine. The machine has their company file on it, or their internal network has their company file on it. They can use it. But as Brad mentioned, Ray, he wants his accountant in his business. He wants to be able to share or get his information to the accountant, so his accountant can work on his books, and then he can take advantage of that. He can improve his business with the advice of his accountant. Now, the process for that at the moment is exceedingly manual. That's very truly, 1990s, where he copies his file to a USB key, he jumps in his car or however he gets to his accountant, drives over to his accountant and actually delivers his company file to the accountant. The accountant then spends some period of time working on it, and then the reverse has to happen. Ray or Trevor have to go back and actually collect the company file and go back to their office. Now, while the accountant's actually got the company file, the small business owner is not able to actually do anything to his business or his business information. He can read what he has, but if he can't update it, because in effect the master copy is held at that point by the accountant. This actually poses quite a significant problem, because you don't want to be a small business and not be able to react quickly in your small business. You want to be able to service your clients, make sales, record your sales, and not have to worry about stuff. So this has led MYOB, and MYOB, for as long as I've actually worked there, has had the vision of connecting the accountant and the small business. And they've kind of expanded on that goal, and now they actually want to involve, connect more than just the accountant and the business, but also devices and all other things that they may have and they want to actually use within their business. So this led the business to a decision point. How do you actually take what we have, which I've described was the WinForms, link to SQL and SQL CE infrastructure, and how do we actually convert that so that actually runs online, on the cloud? So this is where the business itself. All parts of the business actually got together, and so that's product owners, developers, BAs, architects, all parts of the business got together to work on how we could actually get from where we were to where we actually needed to be. Now, this as has been discussed in a few other presentations that I've attended personally, it's talking about having a shared vision. One of the really important things you actually need to do as a developer group and as a development team is you actually need to have a shared vision. If you don't all buy into the shared vision, it makes it very difficult if everybody's going off in their own path. So we agreed on the shared vision, where we were going to. We all wanted to get there. We just needed to work out how we were actually going to do it. Now, when you're going from one of these structures to Azure, there's a lot involved, and it's quite frightening if you just look at it on the surface, but you just need to break it down into its component parts and then deal with each of these problems independently. How do you deal with this? The first thing that we did was we tried to get a handle on all of the components by prototyping and working through what the technologies were and how they could work for us in our implementation. How could we actually refactor our code to support what our needs were? So this is, in effect, a representation, as I've already shown you, of where we're actually at. Now, the fastest way from point A to point B, where we wanted to get to, was to move our existing code base directly into the cloud. So in effect, what we did was we actually took our link to SQL business logic layer and our SQL CE file, but not the actual file itself, and deployed them into Azure. So we're now using SQL Azure, and we're still using link to SQL as our business logic layer as an ORM, using exactly the same design-driven DDD principles in that logic layer. Now, the reason we're actually able to do this so quickly was that because of the clear delineation that we actually had already implemented. So we, in effect, have a comprehensive interface layer between the UI and the business logic layer that actually serves us exceedingly well and actually allows us to redirect all of our calls either to the local client version that you may be running on your desktop or to the cloud. Oop, we'll go back one. Now, I forgot what I was going to say. Yeah. The technologies that we've actually used to implement a lot of this stuff, I've already mentioned the client-side technologies stack. We're actually using WCF over HTTP with a net data contract serializer to allow us to serialize the objects backwards and forward to the cloud. Now that does have its own implications, and Brad will talk to some of those things later. We're actually using shared type across that, which again Brad will actually discuss in a slide or two. Our business logic layer, as I mentioned, is still the existing link to SQL implementation. Our database is SQL Azure. Yep. Now, the other piece of this puzzle is we actually want to be able to have a client-side copy of our file. We want to be able to sync these things together. It's important for the small business that if they do happen to go offline, they actually want to still be able to work or at least have access to their data while they're offline. And we've actually used Microsoft Sync Framework for that. Yeah.
So, I don't need that. I've got my own microphone. So I want to tell you a story about my Uncle Ray. Who here's got a 3G internet connection of some description? Who here has had poor internet connectivity because of that 3G internet connection? I know. Telstra's fantastic. Oops, sorry. So I want to tell you about my Uncle Ray. He's a little bit eccentric. He doesn't just write software, but he likes to fiddle around with electronics and stuff. And he had I don't know if anyone's seen these, but they're a 3G wireless internet thing that Virgin Broadband created about 2 years ago, 3 years ago. So you could have like your phone connected to it and it was all automatic, right? So he had one of these things, but he lives in the hills, in the mountains just outside of Melbourne. And it rains, and every time it rains, the internet connectivity gets really, really bad because the water sticks on the leaves and then all of a sudden it's thicker and it's hard to get through and stuff, right? So what's the cheapest way to fix that problem? Does anyone know? You'd think that, but then you'd have to go and get the phone line and stuff, and the reason why he had this 3G internet thing was so he didn't have to have a phone line. Cut down the tree? Yeah, you could cut down the tree. Install the NBN, yeah. All really move to the city. That's probably not a cheap option. That's getting close. So the easiest way to fix this thing, right, is to make the antenna better. And so what you do is you type onto the internet, Virgin Broadband 3G antenna, and Ray did this, and the first thing that popped up was use a wok. So he's got a wok, right, and he's placed his 3G modem hanging down inside the middle of the wok. And so the wok is working as a parabolic antenna, shooting the signal directly to the tower. So aside from the sheer lunacy of that plan and the fact he's in my family, it works like a charm. It actually works really, really well. And apparently you can even replace it with the mesh woks that they use for deep frying and stuff as well. That works just as well. But as long as no one kicks it or they decide to move the tower, and then you're in trouble because you have to try and aim it and stuff. So the point of this story, as much as it's an amusing anecdote, is that you can't manage what you don't own. We have 700,000 users with different connections all across Australia and New Zealand. They've all got different latencies, they've all got different connection types. Some of them are on WOX, some of them are on enterprise broadband, some of them are on ADSL, God forbid they might be on cable. So you've also got different bandwidths, right? And we've got different machine specifications. So as Doug mentioned before, we could be working on anything. We could be working on a single core 2 gigahertz processor with 1 gigabyte of RAM as our minimum specification, all the way up to a developer machine with 8 cores and God knows how much RAM. So we have to be able to cope with that, right? And what this means is it means we have to deal with making sure the user experience is as good as possible when we move to the cloud. And that's an absolutely critical thing. If you take one thing out of the WOC story, it's make sure your user experience can handle people putting 3G wireless modems inside WOCs.
Catch WOC exception, is that what?
Yeah, catch WOC exception. Perfect. Slide. So the next thing that happens is that potentially a rat might cut through your network cable. Now, I do know now that this is actually not a network cable and is actually VGA cable, but I searched on iStock Photo and it definitely said network cable. So again, with the WOC story and my Uncle Ray, he will also get occasional network downtime, right? It will just stop. And so we need to be able to cope with that in our UI. And so what we've actually implemented is a UI level proxy layer that sits above that yellow API that you saw in the diagrams and allows us to say, well, if there's an exception that's thrown that sounds like something's happened in WCF, we give the user the opportunity to retry. So the screen will go black, or the screen will go grey, it will pop up a message and say, something went wrong while you were trying to do your last action. Do you want to try it again? Give the user the option. The other thing we do is if we've got a read-only list, and the read-only list for some reason is being refreshed while you're at lunch, you don't actually care at that stage. You don't have any data invested in it, you haven't edited anything, you just want to refresh this. It's just asking to get your more up-to-date data. What we do there is we actually put that on a timer. And so we have a 30-second timer that allows the system to try again and try and get itself back up to speed without you even knowing. So you could come back from lunch, you could have had a network failure, it could have reconnected, and we'd be back up and running and you would be none the wiser. So we spend a lot of time working on the user experience in that area. The next one is database, and I think this has come up a couple of times. How many people have gone to practically every other cloud session here today? I have. SQL Azure is a really, really cool technology. I was actually talking to these guys down here about it before the start of this session. And one of the great things is when you have an enterprise SQL Server failure due to a disk dying or something like that, it's usually a fairly bad situation, right? You've got to rebuild all your data. Hopefully you've got a failover cluster so you don't notice so much, but potentially things can go bang really badly and you could be out of action for a while. The one really handy thing about SQL Azure is because you've got multiple copies of your data stored at any one time in multiple different SANs, that they can just switch you across whenever they feel like they need you to. So the other thing that could potentially happen here is because it's all virtual, so you could have multiple instances of SQL Server on the one machine. That machine may actually have someone else on it that's making a whole pile of load testing requests, like this gentleman down here. And it could actually be you could actually be having a degradation of performance because of somebody else's effect. Microsoft have thought about that and they've given an option. And what that option is they will move you off that server. And so they'll balance the load across all of the SQL Server instances so no one is adversely impacted. This works really, really well, but somewhere, somehow, they've got to get the opportunity to move your instance, right? So what they do is they close your SQL connection. So if you're processing a transaction or doing something on the server, and it happens that they need to move you, they'll move you and they'll take you from one server to another, and your SQL connection will close, and then all of a sudden you'll make the same request again, your SQL connection will be fine. It's really, really cool because you don't have to worry about it too much, but you do have to think about retry. And so in a matter of a couple of seconds or even milliseconds, you could actually be back up and working, and you don't necessarily want to tell the user that something's happened in the background that SQL Azure has had a problem with. So the key point out of this is to remember that SQL Azure may close your connection, and you may be able to do exactly the same thing again with absolutely no impact. So in your data access layer somewhere, you should have some version of retry and be able to cope with what happens if you need to retry in the middle of a transaction and get all your rollback strategies and stuff right. Make sense? The last point here is true statelessness. We have 700,000 users, and I don't know if I'm jumping the point, but they're going to wake up at 7 o'clock in the morning. They're going to have a shower, they're going to get in the car, they're going to drive to work. When they drive to work, they're going to open MYOB's application, and they're going to sign on. Now that's going to happen probably between about 8:15 and 9 o'clock in the morning. So our peak load at that time is going to be quite large. So we're going to have a large number of servers at that time to cope with the load. We have to scale up and scale down to suit this, right? That means that what we've aimed for is we've aimed for true statelessness in our WCF services. We can just go and get this right. You can go to any of our servers. So if we spool up another server and you happen to go to that server, it doesn't matter because we do everything from scratch. And if we have a server failure or Windows Azure needs to move an instance from one server to another because we're pushing it too hard and it's impacting someone else, then it will just work. We don't worry about sticky sessions. We don't worry about any of that kind of stuff. We just point our application at a URL and the URL decides for us where we go. So you really should aim for a true stateless system in Windows Azure. It makes your scalability so much easier and enables you to actually upgrade your instances and increase your instance count whenever you want without any fear of reprisal. I have heard a story about someone actually dropping people's logins because the sticky session disappeared, and I'm not sure that's a great user experience. Next. So we were talking about the old application. The old application, the application we first started building was all local. The entire stack was on the same computer. So from our UI, we could make a call whenever we liked, and there was practically no impact on that call. You just make the call and it goes. Unfortunately, we've introduced this problem, and the problem is what everyone calls latency. So if we were tabbing through a set of fields, and we were making calls to our cloud environment, the application would freeze and stop. So what we've had to do is we've had to change our thinking, change our behaviour from a previous WinForms type mannerism to a web forms mannerism where you go and get your data early. So what we've done, is we've basically grouped the calls or reduced the chattiness of our UI layer. So now when we make a call or when we open a screen, we get all the data we could possibly need. When we save a screen, we do one call and we make the save, because the latencies that we're seeing to our SQL or our Windows Azure server is in the vicinity of about 500 milliseconds. So we don't want to have to wait half a second all the way through the application, and we don't want to make 10 calls at the end of the save, because if we make those 10 calls, it means we take 5 seconds of delay on the screen, and no one wants that user experience. The other thing that we've done is we've had to modify all of our validation behaviour. So previously we had a business rule that said, as soon as you leave the field, you must know whether the field is correct or not. That behaviour doesn't really work in a cloud-based environment, because that means you would have to go and ask the server whether that foreign key is still correct, right? If it's deleted or something, we need to know about it, but we don't need to know about it straight away. So we actually got the business to modify that business rule and say that now we want to know about it, but if it takes half a second and the user's tabbed out of that field, it's not that bad, as long as we make sure that when they try and click the save button, we definitely get it right. So we've been able to maintain that constant consistency throughout the application, but also make sure that the user experience is as good as possible. Sorry? Not necessarily. Say, for example, there's a really good example of this. I've got a credit limit of $5,000. I spent $4,900, and then I try and make 2 purchases at once. In our system, it's important from a business perspective that if you spend $200 with one guy, that you don't spend another $200 with the other guy. And it's that kind of validation that we need to know about. Now, we're going to talk about caching and client-side caching in a minute, but we don't also want to bring the whole database back. If we need to do that, then would have just stuck with the sync framework and just used the cloud as a backup repository and an online-only thing, yeah? Cool. So I want to show you something. Remember we were talking about the Net Data Contract Serializer before, and the fact that we use link to SQL? This is our link to SQL account entity serialized, all of that text. It's 47,000 characters. The reason why it's so large is because it contains all the foreign key references to everything that references it. So if you've got a sale, it's got an account. You've got a card, it's got an account. You've got spend money, it's got an account. The list goes on and on and on. It actually impacts our ability to produce small data to send across to a WOC. If we've got my Uncle Ray sitting at home trying to access his accounting data. If he's got 47,000 characters just for one empty account, and he wants to get all 200 of them so he can view the list, that's going to be an awfully large amount of data. So the key point from this slide is that if you're going to use a Net Data Contract Serializer, it works really, really, really well if you need to get a prototype done very, very quickly, but it has got impacts. And that impact for us personally is this section here. Now, sorry for walking across, but that tracked opening balance, you probably can't read the text, but it goes all the way up to here. That's one integer wrapped in one of our classes. It's and it's actually 0. So it's an awful lot of data for a 0, right? Perhaps the better way here is to think about using the iSerializable pattern, implement only those things you actually need to send across the wire when you absolutely need to send them across the wire. Consider DTOs and consider different types of serialization. We use Net Data Contract Serializer because we have a child has a parent, and then the parent has the child in its collection. And that recursive loop actually causes the XML serializers to have difficulties. this was the quickest way to implement what we needed, but you need to just think about it because it does have an impact. I was speaking about the 200 accounts before. If we have 200 field accounts, it's about 9 megabytes of XML. We've compressed that down to about 600 and made a heap of modifications to the way that we serialise those accounts and got them down below 100K. And that's without switching off the net data contract serializer. So it's really worth inspecting your packets, making sure that you've got exactly what you need and only what you need at any one time.
Okay, previously I talked about how we have deployed each of our company files into Azure as their own independent company file. So in effect, we are single tenanted. Every one of these 700,000 companies is going to have their own SQL Azure database. That matches the pattern that we've implemented in the client and allowed us to actually migrate to this infrastructure as quickly as we've actually managed to do it. Now, I also mentioned that every single one of these company files has the capacity to have completely different content. Even the metadata that's actually used, things like lists of tax codes or accounts that are actually used as metadata, can be completely different from one company to the next. Now, this poses a bit of an issue for us for caching. What exactly do you cache and where is the best place to actually cache it? Now, the approach that we've chosen, which gives us the best bang for buck, is to actually cache information within the client. Brad mentioned earlier about how we've reduced the number of calls we're actually making to the server down to a single call. We've actually taken advantage of that single call and we piggyback on it and we indicate to the server the current state of the client cache. So the client holds on to references of a whole lot of metadata, and then when I'm about to make a service request, it actually goes and says, well, what state do I actually have? Now, the state that we're actually reading at this point in time is for a given data type, what was the last change date or change timestamp, how many records are in that data set, and we pass that information up to the server. The server can then do a quick lookup to see whether that information is still current. Now, given our clients' usage patterns, which tend to be very small numbers of users of the product, it's actually likely that the client already has the current information. So one of the ways we achieve this is the first time when you actually log into the client, it actually makes a quick call to say, well, give me all of this client information in the background. It means that you can continue on using the system unaffected. And when the first screen you actually load that does need the metadata, if it hasn't got it, it's actually going to go and get it. This information is then cached in the client and then reused on screen. So a classic example of this is a whole lot of the foreign key references that were mentioned before. We might have a list of tax codes, we've cached them in the client. When a screen opens, the business required us to have the most up-to-date information. So one of our clients can be certain that the information that they have available to them and that they're actually using on the system at that point in time is current. We want to try and avoid as best as we can to try and get them picking foreign key references that are no longer valid. And so we're trying to piggyback, as I mentioned, on this call to make sure that the client is updated. Now, for all of your implementations, you may there's lots of other options as far as caching is concerned. You could use things like memcache, or you could use CDN. What's that one? Customer Delivery Network or Content Delivery Network, which provides a far closer cache of information in Azure, and I believe that's actually hosted in Australia. There's one of them in Australia. But it's not going to work for us given the number of clients we've got and the volume of information that we're actually talking about. Other options was SQL Azure Cache, the same reason there. The best bang for buck for us and for our implementation was actually caching this stuff in the client. So the business, are actually interested in understanding our application's performance, our Azure implementation. So we need to measure how our system can actually scale, what it's capable of, and what kind of costs that is going to infer at runtime. Now, there's a whole lot of issues with this. You could potentially, for your system, you could take an approach of very simplistically, manually actually testing your app and trying to simulate multiple users from within your office. Could get every single person in the QA department to try and log in at the same time, but it's certainly not going to give you anywhere near a predictable or real-world life scenario. So the approach that we've actually taken is that we've formulated a number of typical usage patterns of the system. So for different business types, they typically perform a certain set of actions. Now that's like going in and spending money or purchasing things or creating inventory records, doing general journal records, all this kind of stuff, running report information. Now, also previously we've mentioned that we're actually using shared type, and so the best way, which actually indicates that the client needs every one of our assemblies actually available and to match the deployed assembled versions. So the approach that we've actually taken to execute a test, which is part of our scalability testing, is to actually use integration tests. Now those integration tests, as I mentioned, cover off each of those scenarios and actually execute the service calls in the sequence that our UI would actually execute the calls. It'll return the data, it'll manipulate the data, and then it will call to try and update this information. So what's the best way that we found to actually execute all of that so that we could analyse the performance of the system? Now, we chose to use Visual Studio Load Test to perform this function, but because of our requirement of share type and all of this, it's how do you deploy all of this information up into the Azure space so we can actually execute these tests? And this is where other Azure technologies have come in, including VHD role, or the VHD role. I'm not sure it's actually called that anymore. It might be VM role. Yeah. And to host an instance of Windows Server 2008 R2, which then gives us the flexibility to actually install Visual Studio to deploy all of our assemblies into those instances. And what we've done is we've actually created multiple of those instances to represent a controller and an agent. I haven't actually explained what a controller is. A controller is actually an orchestrator of all of your tests. Given a set of usage patterns, it manages what machine or which agent is actually going to execute your tests. So the controller can be set up, or your load test can actually be set up to say every 30 seconds spool up another 10, 100 users, execute this set of tests in this pattern, pause between each of the executions, and now the controller actually orchestrates all of that information. Now the other thing that the controller does, which is very valuable, is it actually retrieves the performance of all of your components within your system, including the agents and also your web service. So the problem though you have is you need to make sure that all of these components can actually talk together. And this is where another one of the Azure technologies, Azure Connect, actually comes in, which is still in CTP. And it actually allows us within the Azure space to actually create a virtual network so each of our components can actually talk to each other. Once we'd actually implemented all of this infrastructure and we'd actually deployed it, what we were then interested in is measuring all of this information in real time. And you can kind of see an example of what the interface looks like for load test, for those who haven't seen it. It's fully integrated into Visual Studio, which actually gives for a really good experience. It's exceedingly expressive and allows us to record a significant amount of technical information about the performance of each of your components. Now, taking all of this information can actually be quite overwhelming, especially for other people in the business. And so what we've actually done is internally we analyse all of this information that comes out, which is quite a lot of information, and we summarise it into a form which the business can actually absorb and appreciate as well. And just a simple example of what that may be. I think that was about all for that. Yep.
And so what do we do to fix it?
Huh?
We just repeat.
Oh, yes. So in effect what we're actually in is actually a cycle of executing this, analysing, and then fixing these kinds of problems. It poses a number of challenges, and it actually highlights challenges that you actually have within your system once you actually put it under significant load. And you've got to be able to iterate or just continually repeat the cycle, because you actually want to continually improve this. We want to get the most out of our system for the business to reduce their costs at runtime. It's also going to allow the business to more easily scale all of this information, to use this information to forecast the actual running costs of our platform.
So following on from the cost management sort of angle there, we've just got another couple of points that we'd like to make about cost management with Azure. First one is VM size affects performance. So when you are using the Azure virtual machines, if you're uploading a lot of DLLs, for example, and you're running the DLLs from scratch, if you're initializing a new instance, those DLLs take time to load. And we have 150 or 200 megabytes of DLLs that are loaded up at the start of the IIS boot up. And what that means for us is that it takes a little bit of time. And what we've found is if we unnecessarily reduce the size of our instances to attempt to save money, for example, we use lots and lots of small instances instead of large instances, it takes a long time to get those things set up, and we see a corresponding degradation of performance, particularly at the start of the application, but we also see a degradation of performance throughout. Now for us, because we're going to have hundreds and hundreds of these instances floating around, if we were using small instances, it probably makes, and when we scale, we need to scale for that 8 o'clock in the morning when Ray gets up and then connects his WOC to our systems. When we do that, we're going to scale up in orders of magnitude. We're not going to scale up 1 or 2 small instances. We're going to throw a fair number of instances at it. So the thing that we do here is we just use large instances or extra large instances. Extra large instances are really, really cool because it basically means that you own the entire network stack for that machine. So you don't have to worry about someone else stealing your CPU or contention in the network. You basically get straight access. So it's really, really handy to experiment with extra large and experiment with different sizes depending on what you need. Obviously, if you're building a tiny little web app just for playing around with development, then you probably don't need to pay the extra money for the 4 calls that you're not going to use. But it is worth it. The other thing, for example, is we use medium-sized instances for our load tests because the load test agents for Visual Studio can't actually execute on more than 1 thread. So if we're on a 4-core machine, we only ever see a maximum of 25% CPU. So it's a waste of time, or waste of money for us to actually expand that out using Visual Studio. What's your databases? This is an interesting one. SQL Azure has a very interesting model in that if you have a database A, B, and C, and you decide that you want to add database D, they'll charge you for the maximum number of databases that you've had, or you've used or created over that day. So if we use A, B, C, and D, and then we delete A because we don't need it anymore, we'll pay for 4 databases for that day. Now, it's okay if you're only buying 4 databases because they're relatively cheap, but if you're buying 700,000 of them, then it means that you need to really consider that. The next thing, the better way of doing it, the better way of considering it, is to actually say, well, if I don't need A anymore and all I'm going to do is delete it, maybe I can use A instead of D, and then I've only got 3 databases outstanding. So it just cuts the costs a little bit and stops you from, particularly in testing and dev, when you're throwing databases up and down all the time. It just helps reduce your costs a little bit and helps manage that cost a little bit. So it's just something to remember. And the last one, and probably the most important one, is that Compute Emulator helps. So does everyone know what Compute Emulator is? It's a pretend Azure environment you can use on your dev machine. It's really, really good. It works really, really well. It scales up and scales down. It executes multiple instances. It has the same deployment process almost as what actual Windows Azure has. So it allows you to get all of your build processes and testing processes sort of settled down without having to go constantly to the cloud. And it gives you a really good place to do that first step to make sure everything works well before you take the big leap to the cloud. One thing that it's not so good at, though, is if you were to spool up hundreds and hundreds of instances, medium or large instances, for example, it'll let you do that, but then it's sort of not going to be able to emulate that for you. It'll emulate it and it'll do its best, but if you've got lots and lots of contention on 120 instances and they're all taking 4 cores each, you're going to end up having one trumping all over the other, and you won't get the same sort of performance results as if you're working directly in the cloud. So just consider what you're using it for when you do it. And occasionally also, you may get a serialization error or a WCF error inside Windows Azure that you will never see inside Compute Emulator. So it's just something to watch out for. So, summary. We made it to the end. Everyone in this room who uses Windows Azure and SQL Azure will have a different experience. It may vary in degrees, it may vary a lot. Embrace it and enjoy it. This has just been sort of the keynotes of our experience, but everyone will be different. So I thoroughly recommend you have a play and try it out. It's a really interesting thing. We've talked about connectivity, we've talked about the WOC story and what that means for scale or for compression, serialization. We've talked about scalability and user experience and how critical it is to get your user experience right when you're in a high latency connection. And we've also talked about caching, so considering the types of caching that you're using and considering both client-side caches and server-side caches depending on your needs. The one thing I do want to raise is that I think we have a few of them in the audience, but there's been a number of fantastic sessions at TechEd, and I just want to have just a quick read over the ones that I can remember, and I apologise if I forget any that I've been. But I've been to Chris Paget's Azure Connect one. I've heard a very excellent talk from Dave Fallows about Green Button. John and Mahesh, who are here, and also presenting in room 9, had a very, very good migrating ASP.NET talk. And also Matt Dunn's talk about load testing really opened my eyes. So if you get the opportunity, go back onto the speaker port or the schedule builder. Make sure you download those presentations and have a listen to them, because there's some very smart guys here. And there's a number of others of them as well. So take advantage of it and use the extra knowledge that you can gain from here. So final thing is .NET user groups in your area. I know we have a number of .NET user groups. We have a number of presenters at those user groups here today. Take advantage of them. Learn from them. They've got a hell of a lot of experience and they've done a lot of hard yards. So I can't recommend them highly enough. There's plenty of blogs and information floating around. And if you do want to email us, that's our email addresses. And accelerated developer learning is play. So have a play with Windows Azure. You get a free trial. You get a 30-day free trial if you do the right things. Take advantage of it and have a go, have a play. It's the best way to learn. Any questions? Yes? Okay, so that was a question about how do we keep our versions of a client application the same as the versions in the cloud. So it's actually a really good question. It's a question that we've struggled with for a while. But what we'll do is we actually know the version of the application when we first boot up. We have an upgrade wizard that checks the version as it loads up. We'll use that to determine which, we'll have multiple versions of the Azure web applications running for old and new, right? And we'll use those, we'll point the old version to the old machine, and then when we choose to upgrade them as part of the upgrade process, they'll go to the new machine. And So there will have to be a process for people who don't upgrade, and it may be that what we'll do is we'll start with a small number of new versions, and we'll scale those up as we migrate people across. Then we'll scale down the old versions. And that means that we end up with only a small number of old versions, right? And we don't pay so much for it. And then eventually we'll just have to tell them to upgrade or die.
Not in those words, though.
We'll be nice about it, I promise. Yes?
Like after this second session, would you consider private cloud?
So the question was, after this session, would we after the conference, would we consider private cloud? I'm not sure. I haven't actually thought about the question.
700,000 databases, that's a big deployment.
It is a big deployment, but it also means that if we had private cloud, we'd have to have a lot of SQL servers on our own premises and a lot of power and a lot of network. And we can choose to scale that up and down now with SQL Azure, and we pay a fixed monthly cost for it. We don't have to worry about any of the server constraints that you would normally have, like provisioning and making sure end of life. And
Do you know any legal issues with storing financial data in US or Singapore?
So that was a question about legal issues in US and Singapore. I can't tell you because I'm not a lawyer, I'm sorry. At this stage, everything looks good, but if we get a data center in Australia, it makes the question so much easier. And I'm hoping for it because it simplifies everyone's problem and lowers our latency as well. Can I jump over this side? I feel like I've left these guys alone.
How did you find the developer experience in technology moving from the standard link across to the Azure platform? Was it negligible?
So that was a question about how did we find the developer experience changing from a basic C#.NET stack to C#.NET with Azure. The one thing I probably didn't mention is Azure is a platform, right? As Doug mentioned, we've used the same platform, or the same stack, on a different platform. So the only thing we've had to learn is how to deal with that platform. We're still using Link to SQL, we're still using T-SQL, we're still using C#. We use WinForms in the UI, but that hasn't really changed. We just switch from one to the other. And because we actually use Link to SQL as the back end, it means that it computes the queries for us, and any quirks between the two, it handles for us. So it's actually been quite simple. Yeah, thoroughly recommend it.
Workarounds you said to deliver it in SQL. It sounded like normal practices in the normal .NET application. We didn't see that you mentioned it.
You mean the workaround, as in the stories that we're talking? Yep.
Sure that can happen anytime.
Yes, it can, but as it was titled, this is our story, and we've moved from having a totally fixed client with no .NET and no ASP.NET to a client-server application. And yeah, a lot of the lessons are very similar, but some of them are different as well. Okay, I'll go to you because you've been waiting.
Are you guys planning on offering a full SaaS-based solution for those who are happy to work on the cloud?
I hope so. I want to build it.
Were there any reasons why you didn't sort of consider that option first? Instead of client?
Our customers want to have their data locally. It probably comes back a little bit to the question earlier about data sovereignty. They want to be able to work offline and not have to have a connection if they're on a train or something. So we still have, and we also have a really big market share selling that product that's all on one stack. So it's really important for us to still offer that product. The true value in this solution is actually being able to switch and say, I want to go to the cloud today, and just have all of your data move up to the cloud and open that and enable that for you whenever you want it. That's where the real value is for our customers. So providing a whole new application in terms of a cloud-based application, we actually have one as well. It's called Live Accounts. It's totally online only and focused at very small businesses. So it's there if you're starting from scratch and you want an online only solution. Yep. I'll go, just because he's next.
At the beginning, you were talking about how you take your data and you stick to your account.
Yep.
With what you're doing with the databases being in Azure, are you looking at that connection with the account?
Yep, absolutely. That's a critical piece to making this thing work, right? As we said, my Uncle Ray wants his account in his business and accessing his business all the time. So we do actually have something now that allows any of our partners or any of our customers to say, I want this partner to have access to my data file today. And that's a switch that they can turn on and off at any time, and it enables them to log in and see their data file just show up in the cloud list. And all of a sudden, Ray's business is in Doug's accounting firm, and then he can go and work on it. And then if Ray decides that Doug's not a very good accountant anymore, he can turn that off whenever he likes. So we do have that, and it's a critical piece of functionality. I think I'm missing someone there that's had their hand up for a while.
Ask about how you found the actual costs of using Azure, because that's one thing that our interview sessions that they're costing is quite complicated.
Yep.
I was wondering what your experience was in terms of what it actually costs you a month.
I can't tell you what it costs a month because I'm in the billing department. I know we're currently running 120 cores constantly for dev, so I'm sure it's expensive when you're running that many cores. I have heard of an 80-page bill coming out of Azure for our development. As it stands at the moment, this is our future. Moving to the cloud is such a critical story for us, and enabling our customers to work from home whenever they want instead of having to go back to work to get their data file and take it home so they can type in some accounts. That stuff is so critical for us that we just have to do it. Now, that one.
Just going on again from that question about the whole user management thing, but
Yep.
giving access to your account and stuff.
Yep.
How do you go about educating 700,000 clients to do user management?
There was an...
I know it's non-technical.
Yep, no, that's a really good question. There was there's a presentation on a subject called gamification earlier in the piece. They were talking about making things not require a manual. When we have 700,000 users, we really have got to make sure you don't need a manual for it. It's got to be the best user experience that we can find. That's the first step. The second step is an awful lot of support notes and manuals.
Just the other thing I'll say is that as we've actually gone down this path, I forgot to mention it earlier in the thing, but the actual implementation that we've done isn't revolutionary as far as the user experience is concerned. The screen structures and all of that are very, very similar to what they were in the past. There is evolutionary change, but it's certainly not revolutionary. And so most of the users won't find it disconcerting what they're actually seeing on the screen. Yes, it does look different, but it's not comprehensively different. Correct.
There's just a button that says sign on to the cloud.
Yeah. So there's just a couple of extra steps for signing onto the cloud and things like that. But the rest of the workflows of the app are actually unchanged. Yep.
So what would happen with the local cookies? So you're synchronizing them. Any problems there?
Yep.
How are you going to handle that?
So you're talking about the situation where you've got different types of replication between the two sync hosts, whether you want to be master-slave, master-master, slave-master. And yep.
If you sign up to the cloud, then the
Yep.
data is no longer on your machine? Or
Okay, so there's a couple of options there.
how can you work on the domain if you are not
So there's a couple of options there. We allow people to synchronize locally at any time. We also allow them to choose whether they want to synchronize immediately when they first create their file. So they have the option at any time to take a copy from the cloud and bring it locally. And they also have the opportunity to constantly synchronize that data. So at any time they can go offline and use that data.
So
Automatically. There's a heap of questions about conflict resolution. Unfortunately, though, it's probably a bit hard to talk about with a whole pile of people here, but we want to do a presentation on it next year. So vote us up in their evals and we will. Yes? Yep. We assume that the customer is always going to want a local copy of the data for the sovereignty type questions. So we've factored it into the amount of money I believe we're charging for it. If they don't choose to do that, then there will hopefully be one standard pricing model because it's easy for everyone to understand, but I really don't know the full details about it. Anyone else? Oh, right up the back. There's no limit. So the question for anyone who couldn't hear was, we have 700,000 customers, but they only might have 1 or 2 or maybe 5 users. Is there any limitation to that? Can we not go up? We've built our solution for this product on the expectation that it's going to go past that. The previous solution, the C++ solution, really started to get in a lot of pain when you had 5 users. But we've avoided those bottlenecks, and we don't have that problem anymore. So if we wanted to have 700,000 customers with 100 users each or 1 million users each, it really doesn't matter to us anymore. It has no material impact aside from potentially having a data conflict error because someone else has updated the same sale that you have. Yep. So that's a question about single tenanted versus multi-tenanted, right? We've chosen to single tenant all of our data. It makes the synchronization story a little bit easier, and it also means that when we choose to do backups and stuff, we just take the whole SQL Server database back up, and we don't have to worry about splitting that data out and only getting the stuff that belongs to them and all that kind of stuff. So we've chosen to single tenant it for a number of reasons. There are just a couple of them. Yep.
Maybe you have to think about the maximum SQL size, like database size.
The maximum SQL database size. You mean in terms of the, 50 gigabyte limit or something? Yeah. Our average customer data file size is about 300 megabytes. It goes up to about 2 gigabytes. So we usually won't even hit the 5 gig sizes of the databases, so it's not an issue for us. It's another really good reason to go single tenanted. You don't have to worry about sharding databases and stuff.
Have you built any sort of operational systems that you needed to create to monitor, all the SQL instances that you're running and keep track of all of that?
Good question. You want to answer that one? You can say no.
We haven't actually done any of that stuff yet. It's more of a manual process. Yeah. Yep.
We do, because we have to know who gets access to what, we do have a lot of data about how many databases we're running at any one time and where those databases belong. By the time we go live, we will have to have that kind of stuff because we can't afford to. Yep, we need to know all that kind of stuff, absolutely. Yep. It's coming. Yep. We're currently running tech previews, and we're looking forward to it early next year. Yeah, I'm looking forward to it. I reckon it's going to be absolutely fantastic. Our tech preview went to our developer partners yesterday. So they're actually playing with it now. If you're a developer partner, you'd have access to it too. If you are desperate for one, maybe come down and talk to the nice gentleman at the front and he can explain more about exactly how that works. That one, the one with the hand. Hang on, let me grab that hat.
Yeah.
Done. That guy.
That hat really makes me worry about the previous presenter because we found it in the room. So.
Yeah. I'm also very worried about what's in that hat. Hopefully. Any other questions? Yep. When we moved from C++ to C#, we have had a very heavy change, and actually Doug is the man for that.
We're actually using a control set. We actually bought a control set, Dev Express, if you've heard of that, and that's actually got a skinning engine in it, and we've actually taken the time to actually develop our own skin, which helps make the experience consistent across and doesn't actually look exactly the same as what Windows skins are. Yeah.
Thank you so much.
Okay. Thank you. Don't forget the evals as well.
Yeah, please give us evaluations, tell us what we did wrong and how we can be better.